You have all your components. This is your soldering station, and that's where you, over there where you have oscilloscope and power supply. That's where you do your testing. So I usually like to do it closer to the station so that I can take all the components I want and put it here. So the first thing you need to do is turn on your soldering iron, and you can turn on this lamp also because it's dark here, so you can see all the components. Important thing to really remember here is all these things are 120 volt. So you don't want to put it in 220 volt. The moment you put it, there are two things going to happen. One, the circuit break will go off. But that can be fixed. This will, once gone, it's very difficult to replace it. So always make sure that you use the step up and step down converter to convert 220 volt into 110 volt and then connect it. Can somebody give me a little bit of water from water bottle? Yeah. So this is a sponge, and you need a little bit water, and that is used to clean your soldering iron. That's also a very good test to see if your soldering iron is heated enough or not. Usually if it's blinking, this LED is blinking, it means that it's not set to the temperature. When it's off, it means that it was already at temperature. Okay, so I usually like to fix my board with double-sided tape so that when I'm soldering it, it doesn't move a lot. So I'll just take a piece of it, apply at the back, and then I can and then stuff it. Again, all the components, different location depends upon how you design the board. So can someone pull on the computer so I can see different. So it's already on, you just need to, yeah. Password is Fab. F-A-B, Fab. Okay. And if you go to desktop, there is a folder called demo boards. Inside that demo board, there is a folder called RGB board. Can you open the component?
This one or this?
The one which is more realistic.
Yeah. It is loading currently.
Yeah, so when you design the board, you actually decide where you want your resistor, where you want your capacitor and all those things. So you can use that as a template to then solder all your components. So this board I'm gonna quickly solder completely, and then each one of you are gonna mill the board and then solder the board. Okay, so for that you need a soldering iron, which we have here. You need your solder wire, which we have here. I like to have tweezer also because all these components are very small, so you need tweezer. Yeah, so there's a tweezer here. If you don't find it, there are tweezer here. So basically all the parts you will need in the Fablab is here. So let's start with, say, a 1 kilo ohm resistor. So I know the location of the resistor. Yeah, so the resistor is going to come here. Again, I'm going to look for, the res stands for resistor. This is 100 ohm, 490, 1 kilo ohm. So I'll just take out 1 kilo ohm. And these are all assembly components. They're very tiny. So you have to make sure that you be careful. I need two, so I'm just going to grab two of 1 kilo ohm resistor. The way to read the reading on top of the resistor is, if you really carefully look at the number, it's written as 1001. The way to read it is basically it's 100 into 10 to the power 1. So that makes it 1 kilo ohm. If it's 10 kilo ohm, then it's going to be 1002, which will be 100 into 10 to the power 2, which is 10 kilo ohm. So what is 100 ohm? What will be the reading for 100 ohm?
000.
Yeah, so that is kind of a confusing because it reads like a 1000 ohm or 1 kilo ohm. Okay, so now I have two resistors. It's a good practice to put back the bin. Because what will happen is eventually many people will start using and there will be like a mess. And these components once get lost, it's very difficult to find out. Okay, so so there's a very easy way to solder all these things. The first thing I like to do is heat my copper pad. When you heat the copper pad, what happens is the moment you are melting your soldering iron, it will quickly stick to copper pad. If you don't hit your copper pad, what will happen is the soldering iron is just the soldering wire is just going to stick to your soldering iron. So I just keep it. So for example, I want the resistor here. I'm just going to put it like this. Let it heat for a while, and then gently melt the solder. So now I have solder on my copper pad. So now I can use this as an anchor thing. So I'm just going to lift my resistor, put it like this, put on top of that, and simply melt that solder. So when I melt it, because of gravity and because of my force, the component is going to go right on top of the pad, and the melted solder is going to attach to the component pad, and now it's stuck. So it's not very good right now. What I'll do is I'll simply go to the other side, do the same thing. So right now what I'm going to do is I'm going to put my tip such that it's in contact with both the copper pad and the component pad. So it's basically right here. Again, wait for some time so that's heated, and then introduce the soldering wire. And once it melts it's going to melt and flow not only in your copper pad, it's going to flow on your component also. So that makes a very intimate contact. Now once this side is done, I can go back to my other side and do the same thing. Again, heat it up a little bit and then apply a solder. It's a good practice to make sure I've been confident that it's actually making a contact, because as you gradually start to populate your components, there will be like many cases where if it's not making intimate contact, it will be very difficult to debug it later. So once I'm confident that this is perfect, then I can move to a different one. So I'm going to move to a different one. Again, with the diagram, I can see that another resistor is going to come here. So put it here for a while, let it heat, and then gently introduce the soldering wire, and then reflow it. Flow. Pick your component, put it on top of your solder pad with right orientation. Again, melt it. So this will create a loose anchor. So the reason of doing that is, if you don't create a loose anchor, when you are soldering it, your component might move here and there. But once I have created the loose anchor, I can simply go on the other side and attach it properly without worrying about the fact that the component can actually move here and there. Again, heating the pad is a key here. If you don't be patient and not heat the pad, it will be very difficult to do all the soldering. So can anyone turn on the LED again? So other thing is so this is two resistors. What we're going to do is we're going to attach a microcontroller. So the one we are using is AT-Tiny45. It's a 8-pin microcontroller. You can see it there. Now microcontroller has a polarity, as most of you know. Again, I'm going to go here. I'm going to see my AT-Tiny45. Use my tweezer. Grab one of the microcontroller. Now one mistake what many people do is when they want to take out the board, they use the tweezer to take out. These tweezers are not designed to actually sustain any mechanical strength. So what will happen is this tweezer will bend, and then it will be very difficult to pick your components. So a good practice is never use this tweezer for any other purpose than just picking up your components. Now as resistor, I'm gonna first find out where I'm gonna put my microcontroller and check the polarity. And I think this is the polarity. Let me.
I think a different bunch of people can watch the software.
Yeah. Because it's the same thing again and again. So the guys who were in the front can go back, and the other 3 or 4 people can come. Okay, so for soldering again, what I'm gonna do is first I find out the orientation. Now resistors doesn't have orientation, capacitor doesn't have orientation, but LED has a orientation, microcontroller has a orientation. So I'm gonna again go here, heat one of my pad, and then apply a little bit solder. So I'll wait for it to heat. And then apply solder. Now I can use this as an anchoring pad. So I'm just gonna go grab my microcontroller, make sure that it's in right orientation. Also make sure that when I'm putting it, all the LEDs are on top of the corresponding pads, and simply melt my solder. So the moment I melt it, that's going to create an anchor pad so that my component won't move. Now I can go to other pad, and again what I'm going to do is I'm going to use my soldering iron to heat the pad and the leads at the same time. So wait for it to heat and then gradually introduce soldering iron. So this way it will make a perfect contact. So I'm going to repeat the same process with all the LEDs. So I'm going to do one more connector and then I'll ask one of you to finish the entire board. Okay, now microcontroller is done, so I'm going to add one more connector which is called Isp Connector, and that will be used to program your board. Okay, so this is the Isp connector. Again, you can swap places. So what you do is you first start with the pad, you heat the pad, let it heat for a while, and then introduce the solder a little bit. Then, so this is pretty big, so you can hold it with hand, but the small components like resistor, you need to hold it with your tweezer. Put it like this, make sure that all the pads are overlapping with all the leads are overlapping with the pads. Melt the solder, and that is anchored. Now you can go to other part and solder it. Always make sure that you go back to your first track, first solder pad, because that's not very intimate when you do it in the first attempt. Again, the trick is to make sure that both your LED and copper, both your lead and copper pads are properly heated. Now, sometime what will happen is you are trying to say solder it and you create a mess. So, for example, I am soldering this pins and I just added lot of solders. Okay. Now all of the 3 pins are connected. This is a very bad situation because one of the pin can be ground and one of the pin can be VCC. Okay, so if you really just want to take it out with the soldering iron, it gets very difficult. So for that we use this copper grade. So the trick to using it is you hold it with one hand, then you put on top of the mess, and then you apply a little heat and wait for the solder to melt. So I'm just being patient and wait for the solder to melt and quickly take it out like this. So what's actually happening is all the solder, because of the surface tension, it's going to stick to my copper grade. This is also a very good trick if you have a pin which are very close to each other and you can't just solder it. So you can simply create a mass and then take out the excess solder. Okay, so now you can see that the pins are very clean. Okay, now I need a volunteer who will finish the rest of the board. Anyone? Yeah. Now with capacitor, the trick is it doesn't have any reading, so just don't mess up. If you mess up and replace 10 microfarad with 10 picofarad, Then every single project which people will do here, you are smart enough. So I usually take it out and put it back immediately. Yeah, so just put it back now. Now you need to know the location. Why this thing? Yeah, so in that software itself you can export this PNG.
So you can't convert to PNG.
No,
Right away.
no.
But in Proteus, I said that there is an option to convert to PNG.
Where?
Only in to JPEG you will convert.
In which software?
Proteus.
Proteus, I am not.
Yeah, I
familiar
have
with
one
that.
small PCB, so we'll try that.
Okay.
What I can do is I can convert again from JPG to PNG.
PNG,
But I don't
yeah.
know if the dimensions will
Yeah.
be
I think it should have a PNG also.
No, it didn't have.
It didn't have it. We can give it a try.
Yeah.
So first heat it and then use the solder wire to. And when you introduce the solder wire, you have to make sure that it comes at the junction where the tip is touching your copper pad.
So why don't we see usually a flux? Yeah.
Yeah, so these soldering wire is a fancy one, so it already has the flux capability inbuilt in it. Initially, when you start, the hand is gonna move, as you can see.
So that's enough.
No, that's not enough. Yeah. And if it makes a sphere, then it's bad. What it's telling you is your copper pad was not heated enough. If the copper pad is heated enough, it will distribute like flat. It won't make a sphere. If it's a sphere, then it's a bad sign.
Yeah.
No, it's like
just, which way?
it's like
This way?
Yeah. So when you put your component, you have to also make sure that the other side of the component is on top of the corresponding pad. Otherwise, if it's tilted, then it gets tricky to solder other side. And because all the tracks are so close to each other, you also have to make sure that it's aligned and not touching other track. Okay, now it's kind of anchored, so go back to previous, the other track. Put your soldering iron in between the component and the pad, let it heat, and then melt soldering wires there. So this time I asked for volunteer, next time I'll ask for names.
Yeah, closer.
Right. That done.
Yeah, this is good enough. Yeah. Okay, so everyone got the idea? Okay, so why don't then we I really don't like to divide in groups because then everybody don't get the exposure. But yeah, let's do individually. Even if it will take time, everyone will have enough time to do things. So why don't you guys start milling your board? Again, the board is already there, so you don't have to take it out. There is enough space there to mill another board. So one of you can start milling another board, and once that is done, that can come with me and I can assist with the soldering. So it's like a chain. When this guy is finished, then the other guy will be done with the soldering. Okay, so just continue with that.